Hello students, welcome to the interesting chemistry where you will find an atmosphere of classroom teaching. If you want to enjoy a classroom teaching from your study room, then please watch the video of interesting chemistry. In my previous video, I explained you about the quantum numbers, and there are 4 quantum numbers. I explained you very well. In today's topic, I am going to explain you the Aufbau Principle. Think about the objective to learn the Aufbau Principle. The objective of this to learn the Aufbau Principle is to learn the electronic configuration of different atoms of multiple electrons. So, what are the electronic configuration? Suppose this is sodium 11, the atomic number of sodium, there are 11 electrons. You write 281. One way. Second method, 1s2, 2s2, 2p6, 3s1. And the third one, this. So there are 3 methods to write the electronic configuration of any element or sodium. Here I have shown. So these electrons, this first type of the electronic configuration is according to the cell. In first cell there are 2 electrons, in second there are 8, and in third cell there is 1 electron. And this method 1s2, 2s2, 2p6, 3s1 is according to subcell. And this, when you write in this way, so it is the according to these orbitals. It's the way of writing the electronic configuration according to the orbitals. So here in this you can write there are 3 types of electronic configuration method or ways of electronic configuration. Now I am going to tell you the Aufbau Principle. Ultimately electron acquires its place into the orbital, or you can say orbital is the place where the maximum possibility of electron to be found. Orbital is a place in an atom where the maximum possibility of the electron to be found. That is orbital. So electron, newly coming electron or the coming electron will occupy its place in the orbital. So orbitals are filled, or filling of the orbitals. So now you have to understand the filling of the orbitals takes place according to the Aufbau Principle. According to the filling of the orbitals takes place according to the Aufbau Principle. Is this Aufbau Principle? The Aufbau Principle has so many rules: Pauli exclusive principle, Hund's rule, N plus L rule, half filled and completely filled orbitals, their stability. These are all. And fifth one, there may be exceptions. Fifth one, there may be exceptions. So these all are the part of the Aufbau Principle. Aufbau Principle is a German word. Aufbau is a German word that it means build up. Aufbau means build up. Then how will you build up an atom or the electronic configuration of an atom? So it is Aufbau. So Aufbau Principle tells us the energy rule. So in the filling of orbitals, when electron the electrons occupies its place in the orbital according to the increasing of the energy level. So filling of the orbital takes place according to their increasing energies. Filling of the orbitals, please listen to me carefully. Filling of the orbital takes place according to the increasing of their energy. It means the coming electron or the entering electron will acquire that orbital which is lower in energy. So the orbitals which are lower in energy will be filled first, and the orbitals that are higher in energy will be filled later. So it is the rule. So I have written here lowest energy rule. Lowest. It is Aufbau Principle. It is the main rule. It is the main rule. The lowest energy rule. The newly coming electron will acquire and is placed in that orbital which is lower or the lowest in the energy, with the lowest, and the higher energy level orbitals will be filled after filling the lower energy level orbitals. It is the opposite. So to decide, how will you decide the levels of the different orbitals? There are so many orbitals in orbital sp and px, py, pz, dx, dy, and it's in the same f has 7 orbitals. How will you decide? So from these rules, n plus l you will decide. Now I will explain you 1, 2, 3, 4, 5 and 6 these rules. So I think one thing I am going to also tell you, please. When you write in 9th class, in position 19, or when you write the according to cell 2881, and some students ask me that, sir, in the third cell, the maximum capacity of the third cell is 18. There, the third cell can acquire 18 electrons. So why should not 9? Why it goes to fourth cell? It is there. So again, come to this orbital. Here 3d and 4s. Now you have to decide the 19th electron. Where will go the 19th electron? To go 3d or 4s1? You have to decide this. The energy level of the 4s and 3d with the help of n plus rule. I will tell you in this video. So please watch this video to understand this question. So here I have explained. Now I am going to explain you the Pauli exclusive principle. So what is Pauli? Pauli is an example. He told us that there are 4 quantum numbers. So no two electron. Pauli is exclusion principle. I am telling you. Pauli told us that no two electrons of an atom can have the same set of 4 quantum numbers. The same set of any two electrons in an atom, in a multiple electron atom, no two electrons can have the 4 set of same quantum numbers. Then how will you explain it? Give an example of this. Suppose I am taking the example of helium. It is helium, He2, and you write 1s2. You write here 1s2. So as there are 4 quantum numbers, which quantum number? N, L, M and S. As in my previous video, I told you the symbol of 4 quantum numbers, that the principal quantum number, azimuthal quantum number, magnetic quantum number and the spin quantum number. So how will you get the value? Suppose the principal quantum number is 1. It means this is nucleus, this is the first cell, so n is equal to 1. This n is equal to 1. It has subcells. How will you get the number of subcells in this principal quantum number? So I told you the subcell about the value of L. You can calculate the value of L 0 to n minus 1. L is dependent on n. So the value of L will be 0 to n minus 1. Here the value of n is 1. So you write here 1 minus 1. It means 0 to 0. It means the principal quantum number of n, the value of S is equal to 0. The value of S, the subset. It means it has only one subcell. It is not 0, but it is an entity. It is the subcell. So this principal quantum number, it means first cell has one subcell, and the name of that subcell is S. 0 is always represented by S subcell. So the value of S, subcell S, is 0. And then calculate the value of, find out the value. How will you find out the value of M? And in my previous video I told you M is equal to minus L to 0 to plus L. In my previous video I explained you minus M is equal to. So now here minus L to now when you want to find the value of N, so here the value of N minus L. So this L minus L minus 0, 0 plus L, it means 0. So here in this way, here 0, it is 0. So this subcell has only, this is orbital. This is orbital. So here the name of this orbital is also S. And here with the, now in this orbital the electron will come here. The electron now in the fourth quantum number, spin quantum number, there are two electrons. One orbital can acquire two electrons. Have you ever thought that both the electrons are negatively charged? They will repel each other. Then how can they exist in the same orbital? Here. So the answer of that question is this electron, and again this electron have the opposite spin. One electron spins in clockwise and the other electron will anti-clockwise. Both the electron have their opposite spin. One will be spins in the clockwise and second one will be into anti-clockwise. So when they are spinning, when they are in motion, when a charged particle is in motion, that produce a magnetic field. A magnetic field depends on the motion. So here both the electromagnetic field will be of opposite nature. The electromagnetic field, the electron produced by both the electron will be of opposite side. So both the electron can exist in the same orbital. So here, so you have to show here this is plus half. This is clockwise, and again the second electron is also here minus half. Minus half shows as anti-clockwise, and plus half shows as clockwise. Both and they can be this one and this one. They represent this. And upward arrow shows us the clockwise, and downward arrow shows us the anti-clockwise. So the second electron have the same quantum again. So in this way, here this is also zero. So Pauli tells us the three quantum numbers that are n, l, and m may be same, can be same, but the fourth quantum number s will be different. So here in this way, here in the both the electron, there are two electrons. One is spinning in clockwise, and second one is spinning in the anti-clockwise, and the value of n, l, m are all equal. Now I am giving this is sufficient example. Now here, suppose you take the lithium 3 and 1s2 and 2s1. 1s2, 2s1. So find out the value. This is lithium, 2s1. So here there are 2 and 1 and 2. This one and this one. Find out the value for the 1. You will write here this 1, the same. For 1s2, you will write the same values as I have written in helium. Now for this one, 2s1, you will write here 2. You will write here 2. The principal quantum number is 2. Find out the value of 0 to n, 0 to n. Here the 0 and 1. 0 and 1. Here, so this is 0, 0 will come first, here 0 and here 0 and plus half. This is the lithium. So in this way you can explain the Pauli exclusive principle. Pauli exclusive principle tells us no two electrons in an atom can have the same set of 4 quantum numbers. There may be n plus, there is the same value of n, l, and m, but the fourth quantum number, s spin quantum number, is always opposite. One electron will spin in clockwise, and the second electron will spin in the anti-clockwise. This is about the Pauli exclusion principle. Now I am coming to the second one. Which one is Hund's rule? This is Hund's rule. What is Hund's? Hund's is the name of a scientist who told us about the pairing of electrons. First I will give you an example. Suppose you are taking this is boron. Boron 5, 1s2, 2s2 and 2px1, 2py0 and pz0. This is, I have taken boron B5, 1s2, B5 means 2 and 3, and you can write here 1s2, 2s2 and 2p1. 1s2, 2s2, 2p1. This I have shown here px, p1 by pg. Now come to the carbon. This is 1s2, 2s2, 2px1. Now the sixth electron. Now the sixth electron you can write here px1, 2py1 or 2pz0. Same. The sixth electron entered in the 2py, or you can write 2px, both the electron. This 6th electron entered to the px and py still 0 and 2pz is still 0. Both are 0 in the same form. The 6th electron paired up, here paired up, here unpaired. Both the electrons are unpaired, and here this 6th electron is paired up. So this is called the pairing of electron in an orbital. This is called the pairing of electron in an orbital. So Hund's rule tells us when will the pairing of electron starts? When will the pairing of the stars? So no pairing of electron in an orbital takes place until the each orbital of the same subcell has got one electron each. One electron each. What I am saying? Again, listen to me. I am saying that no pairing of electron in an orbital takes place until the each orbital of the same subcell has got one electron each. It means this pairing will not start until, suppose now the carbon, now here the nitrogen will 7 the same 2px, 1 2py, 1 2pz. The three orbitals of the same subcell P has got one each. Of the three orbitals has got one each electron. Now the pairing start. Now the oxygen number 8, it will 2px2, 2py1 and 2pz. And now fluorine, this will 2p2 and so on p2. This is about the Hund rule. This is about the Hund rule. If a electronic configuration comes to you, that write the electronic, which is the right electron. This is n plus 2. I have shown you a table according to the increasing order of the energies of the different orbitals. I will explain you how will you prepare or make this table. So please first learn about the n plus L rule. N plus L rule help us to find the energy of the orbitals. If the value of n plus L is low, then the energy of that orbital will also be low. So here, first I will tell you that how will you calculate the n plus L value. Suppose it is 3d. It is an orbital, and find out the value of n plus L of 3d. It is 3d. So this 3 shows us the value of n. It means it is the principal quantum number. And d, now you have to know about the value of L for d. So I am giving you a table here, S, P, D and F. In my previous video I explained it very well that the L values for S is equal to 0, P for 1, D for 2 and F for 3. So please note it. The value of L for S for 0, P for 1, D for 2 and F for 3. these are the values of L of different subcells. This D is subcell. D is subcell, so the value for D subcell is equal to 2. So you write here 3 and N is equal to 3 and D is equal to 2, so the value will be 5. You can calculate. If I say to you that find the value of 2p, what is the 2p? 2p is 2 plus the value of p for L is equal to 1. So the 2p, the N plus L value of the 2p is equal to 3. So this is the way to find the value of N plus L. I think that you have understood about how will you get the value of N plus L. If I say to you that find the value of 2D, find the value of 2D, N plus L 2D, for the N is equal to 2 and D for 2, you will write here 2 and 2, and you will write here 4. This is for 2D, means 2 plus 2 is equal to 4. You have calculated very well that the value of 2D is 4. But think about this. Whether there is 2D is present in the second quantum number or in the second cell or in the second cell orbit, is there 2D present? No, only the second will have only S and P. So you should know this is impossible to calculate the value of 2D because 2D doesn't exist in an atom. You can't find the value of 3F because 3F doesn't exist in the atom. So the F will be 4F. 4F. F starts from the fourth and 3D starts from the third and 2P starts. If I say to you to find the value of 1P, can you find it? Definitely you will say no. P, there is no P in the first orbit or the first cell. So you can. So please be careful. If you have if you have a question in which some orbitals are given and find, so the cells are given and a question is asked that you find the value of N plus L. So first confirm the existence of that subcell. So it is the. So I think that you have understood about the finding the value of N plus L. Now write the simple. One first cell has only one S, second 2S 2P, third 3S 3P 3D, 4S 4P 4D and 4F. In the same way 5, and I think that you have understood how to write this all the chart as I made it. Now I am telling you how will you decide the energy of a particular cell is higher or lower. If the N plus value of a particular cell is greater, then it will be greater in energy. It will be higher in energy. If the value of N plus L is low, then it will be low in energy. So N plus the value of N plus L shows us the order of increasing the energy level of the subcells. If you write the value N plus L value of the subcells in an increasing order, then increasing order, it means you are showing that the subcells in the increasing of the energy of that cells. So here as the n plus L value increases, the energy of that cell will also increase. The n plus L, if the n plus L value is lower, then the subcell is also low in energy. Higher the n plus L value, higher the energy, lower the n plus L value of a orbital, then it is lower in energy. Suppose, no, first thing, it is the first part of the n plus rule. Now the second part of the n plus rule. If two cells have the same value of n plus L, suppose I think that this is at 3p, this is 3p and it is 4s, the value of n3 plus 1, n is equal to 3, the p, L for p is equal to 1, L for p is equal to 1, so it is 4. And the value of 4s, n is equal to s and s is equal to 0, it is also 4. It is also 4. So, if in that case, if the value of the n plus of the two orbital or more than two orbitals are equal, then how will you decide the energy level of that orbital? So, please, the orbital that have the lower number of principal quantum number. It means the principal quantum number. This is principal quantum 3 and this is 4. If it is greater in the principal quantum number, it is lower in principal quantum number. So the energy, the orbital that have the low principal quantum number value or the low of the n value, that is lower in energy level, and the orbital that has the higher principal quantum number is greater in the energy level. It is higher in the energy level. So in this case, on this behalf of, I have written this made up this table. So I am going to explain you how did I make this table. So here it is. So come from the right hand side, from up towards left hand side downward. You will write for here first S. You will write here first S. Now come to again right hand side upper and left downward. Again it is 2S. Then 2P to 3S. 2P 3S. Then 3P 4S. 3P 4S. Then come to the right side 3D 4P 5S. 3D 4P 5S. Then come to this 4D 5P 6S. 4D 5P 6S. And come that 4F 5D. 4F 5D 6P. 4F 5D 6P 7S. And so on. And so on. Now come to the here 5F. If you need to write the 5F, then you can write here 5F. So here, now I have given 1S, 10, 2S, 20, 2P1. So these are the totals. You have written the value of N, and 1, 2, 1, 2, 3, 4, this 4, and this is 4F, so 4, and L, the value according to this table, you have written the value of the L. So the total 1, 2, 3, 4, 5, 6, 7, and so on, 7. This is 8. These are the value n plus L values. These are the n plus. This is the ascending order according to the energy of the subcell. According to the energy of the subcell, this is the ascending order. The order of the filling of the orbitals will be decided with this table. So 3s will be filled first, 3p will be filled later. So 3s and 3p. Now you can find out that which subcell will be filled first, or the coming electron will, in which cell the coming electron will go. Or you can say, in other words, in which orbital of the subcell the electron will acquire first. So here, with this table you can calculate. Now I am telling you the fact. These are the n plus values. There are two values, 3 and 3. There are 3. So 2p and 3s both are equal in n plus L value. Here the principal quantum number 2, here the principal quantum number 3. So the coming electron, newly coming electron will enter to the 2p before 3s. Before 3s, because here the principal quantum, the value of the principal quantum number is more than 2p, so 3s. So 3s will be filled later and 2p will be filled first in this case. In this here there are 3 6. There are 3 6. These all are equal in the n plus L value, but the principal quantum number is 4, 5 and 6. So the coming electron will prefer to enter in that orbital which has the least value of n, 4, 5 and 6. The value of this 4d is least, so the coming electron, this 4d will be filled, the orbitals of the 4d will be filled first, then the 5p orbitals will be filled, then the 6s will be filled. In this way, this is the chart, this is the way how will you write the electronic configuration. So by finding the value of n plus L, you can decide the energy level of the each and every, whenever you suppose now come here, I have given you a question. Which one question? That potassium. Here, this is potassium. This is 19 potassium. Then so you have written 2881, 289. Not. It is not. We have told you in the ninth class that the electronic configuration of potassium is 2881, and you asked me that the maximum capacity of the third cell, or it is 18. So why don't the 19th electron enters to the third cell to form 9. So I tell now write here 2828 and write here 3s2, 3p6, 3d and 4s. So now you have to decide the 19th electron will either go to 3d or 4s. In which orbital the 19th electron? So calculate the value, find the value of n plus L. The 3d n plus L is equal to 5, 3 d2, 3 to 5, 4s. 4 plus 0, it means 4. So the value of n plus L of 4s is lower than the 3d. So the coming electron will go to 4. So it will be right and this will be wrong. I have explained it. So I think the confusion that you have in your mind, you are carrying in your mind from the 9th class, today I have explained, I have cleared their confusion that the coming 19th electron will go to the 4s, not in 3d. This is the, and so this Aufbau principle, as I explained you, the Pauli exclusion principle and the Hund's rule and the n plus l rule, these all three helps us to write the electronic configuration. So so we have to take care, we have to observe these rules when we write the electronic configuration of different atoms. So now I am giving you the fourth, that is the half-filled and full-filled and the orbitals. Suppose I ask you that nitrogen is present in the atmosphere. Nitrogen is about approximately 75% present in the atmosphere, and nitrogen is there and oxygen is there. How can it is possible that nitrogen and oxygen, no reaction? When oxygen has in the burning, oxygen reacts with all elements to form the oxide, but nitrogen and oxygen don't react with each other in normal temperature. I am saying about the normal temperature. No, in reacting threading or higher temperature, they also react with each other, but in normal temperature they exist separate, they don't react with each other. Why? So come to the electronic configuration of nitrogen. The electronic configuration of nitrogen is nitrogen number 7, 1s2, 2s2 and 2p3. So this half filled, this p subcell is half filled. So it has more stability. It has more. So you have to say, now I am going to the half filled. Half filled orbitals are like 3p3, d5 and f7 or p6, d10 or f14. Whenever you find in electronic electron configuration that these states P3, D5 and these P6 and D14, these have more stability. They are more stable than the incomplete subcells. So you can say that P2, if there is a condition of P2 and P3, so P3, the element that have the P3 electronic configuration is more stable than P2. If any elements have P5 and P7, so P5 is more stable than P7. It is so you can say half-filled and full-filled orbitals, all the subcells, because orbitals are the part of subcell. So you can subcell all orbitals, then the stability increases. Now why? Because when the incomplete or the half-filled orbitals are there, suppose these are the P3. These P3, all the 3 electrons are unpaired. All the 3 electrons are unpaired. In D5, all the electrons are unpaired. D5 unpaired. This is unpaired. And they have identical spin. similar spin. They all are clockwise spin. They have all clockwise spin. If there is a symmetry, there is a symmetry. There is a symmetry. Or when there is a symmetry, there is a stability. When there is a symmetry, there is a stability. So they all have the same spin. If they have the same spin, the clockwise spin, similar to spin, so they are more stable than any other condition. If there are 4 and 6, the stability, the similarity, the symmetry will be disturbed. If there are 7 electrons, the symmetry will be disturbed. This is not symmetrical. It is symmetrical. And if it has 6 electrons, then this that is asymmetrical. That is, the symmetry has disturbed. So the stability will be disturbed. So in this way, you can say the half-filled or the full-filled orbitals or the subcells are more stable. They tends to acquire the half-filled orbital. I will explain you in the chromium and iron. I will explain when I will go to teach you the electronic configuration of all elements. Then I will explain this. But today you should remember the half-filled and the full-filled orbitals are more stable than other orbitals. So I have explained you one cause, the similarity. The second cause. There are 2 causes behind the stability of the half-filled and the full-filled orbitals. First, I have explained the symmetry, or they have the identical spin. So there is the symmetry, the stability increases. Second cause. This electron can exchange this one, and this electron can come here. This electron can come here, and this electron come here. The electron can exchange its place in exchange because they are identical. They have identical spin. So when they exchange their places, the exchange energy will be evolved. Due to as much energy will be evolved, the stability increase. So they have, this electron have 5 possibility to exchange. 4. One, this electron can go here, can go here, can go here. So this have 4 probability to exchange. So when there is an exchange of the electron, so the exchange energy will be evolved. When energy evolved, there is a decrease in energy, so the stability will be increased. That's all for today about the Aufbau principle. I have explained you both the Pauli's exclusion and the Hund rule, the n plus L rule, or the stability of the half-field. I think that you have understood. Please, if you learn something from my video, I think that so please tell your other friends about this video. Share my video to your other friends, then they could also take some benefit from this video. This video, the content of this video. If you learn thoroughly this video, you will never do any mistake in writing the electronic configuration. Please note it. My coming video, I will give you according the classification of the all elements with the help of this electronic configuration. I will explain the electronic configuration, all elements and the classification. So please, how will you make the periodic table, or how will you write the electronic configuration? I will give you explain you the all electronic or the all all elements electronic configuration in my coming video. So please continue to watch my video. Please share and like this video. For today it's okay. Thank you very much.